All right. So once the potential difference was done, we were supposed to get into EMF, but in order to understand electromotive force, we need to first understand the working of a battery. So we spend a lot of time yesterday on battery, not essentially battery, but what's happening inside an electrolyte. That's what we actually focused on. So we'll move on from that particular location. So I just want to revise quickly what we did related to the electrolyte yesterday. And from there, we'll focus on how a battery works, what happens when the battery is connected to external wiring, like a bulb and all, if it is connected, what happens? We say a battery gets drained out. So we need to understand why it gets drained out. All right, so ground rules. First and foremost thing, don't draw anything on the screen, guys. If everyone is getting disturbed, there are few very kids who are really interested in this subject. So don't disturb them. If you're really troubled, I think you can leave. We can speak to Srini, we can speak to Abir sir about it, and maybe he'll excuse you. You can just leave. And also, at the end, you are getting frustrated, and if you cannot bear, I mean, I'm definitely going to take the class till 6 o'clock. We'll have that 10 minutes break also in between. So till 6, if you're not able to bear, you can actually leave. It's okay. I mean, there's no pressure on you, right? Your regular teacher has already taught you this. You have your textbook. This is all extra. I mean, for your future, this is an investment, as I told you, time investment that you're laying for your future if you're interested in science field. So this is one of the fundamental topics of advanced sciences. So it's up to you. So there's no pressure on you. Whoever wants to leave at that juncture, maybe around 5:30 and all, you can decide and you can leave. Even if there is a single student, I'll just continue with him, okay, or her. Right. All right. So let's move on from where we stopped yesterday. I want to see chat window. Yeah, thank you guys. I got a lot of good afternoons. Thank you. Thank you. All right. So a quick recap on what we tried to understand yesterday. So my question started with what happens when sodium chloride salt, the solid material, the crystals are dropped in water. So we concluded that sodium ions and chlorine ions get separated. My next question was, since one is positive charge and other one is negative charge, why are they getting separated? Why are not they not getting attached again? So the reason for that is water molecules. So the water molecules, as you can see on the screen here, H2O, and this red color one is Na plus, green color one is Cl minus. So water molecules are essentially separating them because water molecules also have charges on them. They're not purely covalent bond. They have some ground charges, surface charges. So they are actually separating them out. They're separating Na plus and chlorine minus ions. So the conclusion from all this discussion is single thing. The electrolyte, the liquid, the foundation liquid in this particular solution is water. So water is separating the most important charges, Na plus charges and Cl minus charges. And these water molecules will push these positives to one direction and negatives to the other direction. So that is the foundation, why these ions are formed and why these ions move separate to each other. That is the foundation for understanding the battery. All right. So we are moving to the main slide now. So here water molecules are essentially, yeah, Himesh asked me, so water molecules attract Na plus and Cl minus ions. It's more than attraction, they're more focused towards separation, because as you can see over here, O minus, it's a negative charge, so Na is a positive charge. It tries to, it really does not have the capability of completely attracting it, but it has the capability of separating Na plus and Cl minus. And it's not just one water molecule, guys. These Na plus and Cl minus ions are surrounded by thousands and thousands of water molecules. They're buried inside water, right? So all this combined effect is what's happening to this Na plus and Cl minus ions. So Na plus goes to one side and Cl minus goes to another side. So these 4 stages, there are 4 stages of the battery. 5th stage is when you connect a wire to a battery. So let's talk about these first the 4 stages and then the 5th stage. And all these diagrams are from your textbook. So I did not put anything new over here. And before we move on, so another thing we need to conclude from this particular slide, is since there is a force that is pushing sodium ions and chlorine ions away from each other, a force is pushing both of them away from each other. So that force we are calling the chemical force, FC. This is the chemical force, that's FC. So just remember, uh, whatever chemical force, that chemical force is given by the foundation liquid. Like you have solubility things, right? One is called solvent, one is called solute and all. The solvent is the water. Imagine solute or this NaCl salt. Okay, so that solvent, the main liquid in which everything is poured, that is actually responsible for this chemical force. And what it is doing is it is pushing or it is separating this positive and negative ions. So this slide is a wonderful slide to show the effect of chemical force. So what's happening over here is that chemical force or water or whatever foundation liquid is pushing all the positive charges. So you can see these blue colored ones, all the positive charges to one side of this room, and all the red color negative charges are moved towards the other side. And the only force that is in this particular picture is the chemical force. So stage one, or this first stage that we are discussing for a battery, is related to the chemical force that's acting on these particular ions. So, and these electrodes, as you can see, these particular electrodes in the corners, one green and one dark blue or violet. These electrodes, what they are essentially doing is they're supporting this separation process. So these electrodes can support all the positive. For example, the right side one can support all the positive charges, and the left side one can support all the negative charges. Okay, so that's the first stage. And now let's look at the second stage, what's happening. So because of that chemical force, some negative charges, just a second, yeah, I'm moving it to the center of the screen. Yeah, some of the negative charges move towards the left and some positive charges move towards the right. So this is purely because of chemical force. Now, when this happens, I want you to carefully listen to my next statement. Now, these are all negative charges on the left. One more negative charge is trying to come close to this. So what happens is the already existing negative charges, they kind of repel it a little bit. They don't have the capability to throw it out completely, but they tend to repel a little bit. This particular new force that is actually repelled by the plate onto the ions is called electric force. Guys, once again, chemical force always try to push these ions towards the towards one of the electrodes, either the right side or the left side electrode. The chemical force pushes them. Whereas there's a new force, it's called electric force. Why it got generated was because already there are some ions on the plates. On this side you have negative ions, and on this side you have positive ions. What these ions are doing is they want to have more space. Okay, they're very individual, they don't want newcomers, so they're trying to resist the new ions that are trying to come. Chemical force is still pushing this ion. Chemical force is pushing this red color ion towards this plate, but these ions are actually repelling it. So that's why this is the second force, and this particular smaller arrow corresponds to this electric force. Here the same thing is happening. Chemical force is trying to push it towards the blue color plate, whereas this particular plate with all its ions is trying to repel this one, trying to not allow it closer. But as you can see here in this image, chemical force is stronger than the electric force. Chemical force is the long one, and the electric force is the short one. Again, even on this, chemical force is the long one, which is helping it to go towards the plate, and electric force is the short one, where the plate is actually pushing it back towards the center. Okay, but as obviously what you can see over here is chemical force is greater than the electric force, right? So the process continues. Over here, what you're observing is chemical force is the longer arrow, which is far more greater than the electric force. So the process of accumulation of ions towards the plate will not stop. As long as chemical force is greater than the electric force, this process continues. And because of that, so the stage two, we introduce electric force, and also we introduce that chemical force is still greater than electric force. So this accumulation of ions will continue even now. All right. Now let's move on to stage 3. Now, at this particular stage, I don't have any chat window activated. Good, you're carefully listening. So continue listening until this battery thing is done. And as soon as battery is done, we just have to define what is electromotive force, and then we'll start with our main activity, Ohm's law. Okay. Now, I hope you're enjoying this particular thing. It's kind of a story, what's happening inside this battery. Okay, we started with understanding how a chemical force is generated. If you remember, it's because of the water, the solvent in the electrolyte. Because of that, the chemical force originated and the ions are pushed towards the plates. Now, electric force got generated because ions, already there are already few ions on the plates. They don't want new ions. They want to have more and more space. So they're trying to resist the newcomers. Okay. So that's, you might have experience, you might have had a best friend or something, and when new guy comes into the picture and wants to start friendship, you might have resisted at least a little bit, something like that, you can imagine. Okay, so electric force originated because of that repulsion from the plates. Okay, and as chemical force was greater than the electric force in the stage 2, this particular accumulation happened. And after few more minutes or few more seconds, whatever, as you can see in this picture right now, more accumulation happened. And at this particular stage, you can observe there are lots of ions over here. It's kind of a saturation state that's happening over here. So when there are lots of ions, the chemical force is still active. It's trying to push the ions towards the respective plates, but the repulsion force has also increased. There's no new, I mean, there might be a lot of space still on the plates, but all these ions that are existing on the plates, they are causing real problem to the chemical force. They are repelling whatever that are coming closer. The positive, for example, this right side one is repelling this positive one. So the electric force at this stage, the stage 3, electric force and chemical forces are balanced. That means the force responsible for pushing the ions towards the plate is balanced by the force that is responsible for pushing the ions by the plate. That means towards the center. Okay, I want to repeat this in Telugu in case you missed out. So Telugulo చెప్తున్నాను. ఇక్కడ జరుగుతున్నది ఏంటంటే ఎలక్ట్రోలైట్ కెమికల్ ఫోర్స్ తోటి ఈ అయాన్స్ ని, ఈ రెడ్ కలర్ అయాన్స్ ని రెడ్ సైడ్ అంటే ఈ లెఫ్ట్ సైడ్ ప్లేట్ కి తోస్తున్నాయి. అలానే బ్లూ కలర్ అయాన్స్ ని ఇక్కడ ఉన్న వాటర్, లోపల ఉన్న వాటర్ మాలిక్యూల్స్ ఈ రైట్ సైడ్ కి తోస్తున్నాయి. అది కెమికల్ ఫోర్స్. కానీ ఈ కెమికల్ ఫోర్స్ ని బ్యాలెన్స్ చేస్తూ ఎలక్ట్రిక్ ఫోర్స్ వచ్చింది. ఆ ఎలక్ట్రిక్ ఫోర్స్ ఎందుకు వచ్చిందంటే ఆల్రెడీ ఎగ్జిస్టింగ్ అయాన్స్ కొత్తగా వచ్చే అయాన్స్ ని యాక్సెప్ట్ చేయట్లేదు. దే ఆర్ పుషింగ్ దమ్ అవే. సో ఈ కైండ్ ఆఫ్ బ్యాలెన్స్, కెమికల్ ఫోర్స్, ఎలక్ట్రిక్ ఫోర్స్ ప్రతి అయాన్ మీద బ్యాలెన్స్ అయిపోయింది. బ్యాలెన్స్ అవ్వటం వల్ల ఇంకా అయాన్స్ ఎటు మూవ్ అవ్వవు. దే స్టే ఎట్ దేర్ ఓన్ లొకేషన్స్. దే డోంట్ పాస్ టువర్డ్స్ ద పోల్స్ ఆర్ దీస్ ఎలక్ట్రోడ్స్. ఈ పర్టికులర్ స్టేజ్ లో మోస్ట్ ఇంపార్టెంట్ ప్రాపర్టీ మనం నేర్చుకునేది అయాన్, సెంటర్ లో ఉన్న అయాన్స్ మీద కెమికల్ ఫోర్స్ అండ్ ఎలక్ట్రిక్ ఫోర్సెస్ ఆర్ బ్యాలెన్స్డ్ అవుట్. So because of balance, there is no new accumulation on the plates. Since there is no new accumulation, everything is kind of a stable state. And e particular time lo, meekoka e particular scenario lo, there will be some sort of a potential difference. For example, meeku already telsu 9 volts battery. You know this 9 volts battery. When you purchase a brand new battery, this is the stage 3. The chemical force and electric force inside this battery are balanced. So there is this perfect stability, and there is a lot of potential difference established. The potential difference between these two is 9 volts. That 9 volts exists because of essentially the number of ions on the plates. You have these ions. It depends on the number of ions, and also it depends on the types of ions actually. Okay, so this stage is the brand new battery stage. I hope you understood this whole thing. Now this is all good. Chemical force is balanced by the electric force and battery is in a stable state. What if you connect this battery to a bulb or to any copper wire and close a circuit? Okay, so yeah, this is the stage 4 where everything is balanced, and this is the new battery where whatever you purchase from the shop. Now, let's try this out. I want to draw a circuit right now. I want to close this circuit. This is brand new battery, and I'm closing this circuit. I can put a bulb if I want to, but even without bulb, the same process continues. This wire, the new wire that we have drawn, that we drew just now, is an energy consumer. Okay, you can put tungsten or whatever high resistance wires you can put, and that is an energy consumer. If you add a bulb to this, even that bulb is also energy consumer. So now let's see what happens. As soon as you connect these wires, and you already know this process actually, so let's move on. I want to bring it back to the center. Now let's see what happens right now. Before connecting, our status was stage 3 or stage 4, where Fc was equal to Fe. Electric force and the chemical force were the same on all the ions. Whatever ions existed inside, all those ions had balanced forces, so they don't move anywhere. Now, as soon as you connect this battery to external wiring, what happens right now is we have electrons that are attached. So this external wiring, whatever wiring that you are seeing right now here, let me point that wiring out here. So this is the wiring. So this particular wire and this particular wire are there. Over there, you'll have lot of electrons coming in. Okay, so I'm just drawing green. Let's say when you connect, some of the electrons got attached. So the reason is simple, because that plate is a positive plate. Positive charges are attached to it from the inside, so it's a positive plate. And since it is a positive plate, some electrons which are negatively charged, they go and attach to this battery. Same thing, I mean, not attachment, essentially. Here also there are lots of electrons, but what's happening over here is there is a repulsion action. These negative charges on the plate, they are repelling all these green balls, the green electrons. So that repulsion, I'll just point out with black. Okay, so there is a repulsive action because of this plate, and there is an attraction option because of the right side plate. Okay, before I move on to the most important concept in this entire thing, I want you to understand what's happening here. When you connect an external wire, that wire has lot of free moving electrons. We already know why that is. Okay, metals have those free electrons. So all those free electrons, some of the electrons go and attach to the other side of the plate, like this, because this plate is a positive plate and electrons are negatively charged. And what's happening here is those electrons cannot go and touch this particular plate. Why? Because these particular things, whatever you are seeing over here, these negative charges are pushing out the electrons. They're not allowing the electrons to come close to the plate. So when this thing happens, suddenly these ions, they experience one of these forces. So let's try to imagine which force is getting activated. Is it the, these ions, they were actually stable, they were happy. But because of the new electrons that are coming into this story, there is an imbalance of these forces. These ions will experience new forces. So let's try to understand. Okay, so let me slow down a little bit, and I would rather do it in Telugu so that everyone understands. So ఇక్కడ ఏం జరుగుతుందో జాగ్రత్త చూడండి. ఒకవేళ ఈ ఎలక్ట్రాన్స్ అంటూ లేకపోతే ఈ ప్లేట్ పనేంటి? దాని ఎలక్ట్రిక్ ఫోర్స్, అంటే ఈ ప్లేట్ ఏం చేస్తుంది, కొత్తగా లోపలికి వచ్చే ఎలక్ట్రాన్స్ ని అపోజ్ చేస్తుంది. అంటే దాని ఎలక్ట్రిక్ ఫోర్స్ మొత్తాన్ని లోపల ఉన్న అయాన్స్ మీదనే ఫోకస్ చేస్తుంది. Guys, I hope you understood. These plates, what they're doing is they were focusing before these electrons came into the story. The focus of those plates was to not allow any charges, whatever charges are inside, they don't allow them to come close to the plate. Now, what's happening right now? Because some of that electric force, దీంట్లో ఉన్న ఆ ఎలక్ట్రిక్ ఫోర్స్ ఏమైంది, ఇప్పుడు లోపల వాటి మీద పూర్తిగా ఫోకస్ చేయలేకపోతున్నాయి. బయట ఉన్న ఎలక్ట్రాన్స్ వాటిని డిస్టర్బ్ చేస్తున్నాయి, కాబట్టి కొద్దిగా ఎలక్ట్రిక్ ఫోర్స్ వీటి మీద అప్లై చేస్తున్నాయి. ఇక్కడ ఏమవుతుంది, ఈ ఎలక్ట్రాన్స్ వచ్చి ఈ రైట్ సైడ్ ప్లేట్ మీద అటాచ్ అవ్వగానే ఇది సప్లై చేసే ఎలక్ట్రిక్ ఫోర్స్ కొంచెం తగ్గిపోతుంది. సిమిలర్ గా ఈ నెగిటివ్ చార్జెస్ సారీ ఈ ప్లేట్ మీద ఉన్న ఎనర్జీ కొంత ఎనర్జీ ఆ ఎలక్ట్రాన్స్ ని రిపెల్ చేయడానికి వాడేస్తుంది. అంటే దాని దగ్గర ఉన్న టోటల్ ఎలక్ట్రిక్ ఫోర్స్ లో కొంత ఎలక్ట్రిక్ ఫోర్స్ ని ఈ విధంగా పుషింగ్ యాక్షన్ కి వాడింది. సో ఆబ్వియస్ గా ఏమవుతుంది, సమ్ ఆఫ్ ద ఎలక్ట్రిక్ ఫోర్స్ హాస్ రెడ్యూస్డ్. ఆ రిడక్షన్ అంతా ఏమవుతుందంటే లోపల ఉన్న ఎలక్ట్రాన్స్ మీద సడన్ గా ఎలక్ట్రిక్ ఫోర్స్ తగ్గిపోతుంది. ఎలక్ట్రిక్ ఫోర్స్ తగ్గిపోతుంది కాబట్టి ఆబ్వియస్లీ లోపల ఉన్న ఎలక్ట్రాన్స్ మీద కెమికల్ ఫోర్స్ ఇంక్రీజ్ అయిపోయి ఎలక్ట్రిక్ ఫోర్స్ డిక్రీజ్ అయిపోతుంది. ఓకే, ఐ వాంట్ టు సమ్మరైజ్ దిస్. ఫస్ట్ ఒకసారి తెలుగులో సమ్మరైజ్ చేసి ఇంగ్లీష్ లో సమ్మరైజ్ చేస్తాను. సో లిసన్ కేర్ఫుల్లీ, అందరు వినండి. నార్మల్ గా ఎలక్ట్రాన్స్ లేకపోతే ఈ ప్లేట్స్ దగ్గర ఫర్ ఎగ్జాంపుల్ 100 న్యూటన్స్ ఎలక్ట్రిక్ ఫోర్స్ ఉందనుకోండి. ఆ 100 న్యూటన్స్ ఎలక్ట్రిక్ ఫోర్స్ మొత్తం వాటి ఫోకస్ అంతా లోపల ఉన్న అయాన్స్ ని తోసేయటానికి వాడుతున్నాయి, బోత్ రైట్ సైడ్ అండ్ లెఫ్ట్ సైడ్ ప్లేట్స్. కానీ ఇప్పుడు కొత్తగా ఈ ఎలక్ట్రాన్స్ రైట్ అండ్ లెఫ్ట్ నుంచి రావటం వల్ల ఏం జరిగింది, ఆ 100 న్యూటన్స్ లో లెట్స్ సే 30 న్యూటన్స్ ఈ అట్రాక్షన్ ని ఈ అట్రాక్షన్ కి హెల్ప్ అవుతుంది, 30 న్యూటన్స్ ఇక్కడ రిపల్షన్ కి కూడా హెల్ప్ అవుతుంది. సో 100 లో 30 న్యూటన్స్ యూజ్ చేసేసుకున్నాయి. సో ఓన్లీ లోపల ఉన్న అయాన్స్ మీద 70 న్యూటన్స్ మాత్రమే ఉన్నాయి. సిన్స్ 70 న్యూటన్స్ ఎలక్ట్రిక్ ఫోర్స్, కానీ పాత కెమికల్ ఫోర్స్ ఇట్ స్టిల్ 100 న్యూటన్స్. సో 100 న్యూటన్స్ ఉన్న కెమికల్ ఫోర్స్ 70 న్యూటన్స్ ఉన్న ఎలక్ట్రిక్ ఫోర్స్ కంటే ఎక్కువ కాబట్టి సడన్ గా ఈ అయాన్స్ అన్ని మళ్ళీ ఈ బ్లూ కలర్ అయాన్స్ అన్ని ఈ ప్లేట్ దగ్గరికి వస్తాయి, రెడ్ కలర్ అయాన్స్ అన్ని రైట్ సైడ్ లెఫ్ట్ సైడ్ ప్లేట్ కి వెళ్ళిపోతాయి. ఈ విధంగా ఎప్పటి వరకు వెళ్తుంటాయి, మళ్ళీ కెమికల్ ఫోర్స్ ఎలక్ట్రిక్ ఫోర్స్ బ్యాలెన్స్ అయ్యేంత వరకు ఇలానే జరుగుతూ ఉంటుంది. ఓకే, so I don't know if some of you only speak English in your class, so I want to repeat it once again in English. So when there was no external electrons attached to these plates, the total force, imagine the electric force that can be supplied by these plates is 100 newtons. So all that 100 newtons is focused in not allowing these ions. The electric force is 100 newtons. Now, since these electrons are disturbing this whole picture, let's say 30 newtons are used up by these electrons. They're disturbing, so some energy is wasted in controlling these electrons. So out of that 130 newtons is gone. So only 70 newtons of electric force is experienced by the ions that are inside. The chemical force was 100 newtons, but electric force is only 70 newtons. So there is an imbalance. And as you already know, what chemical force does is it pushes ions towards the plate. Electric force pushes the ions away from the plates. That is the difference. So since chemical force is greater than the electric force, all the ions will start move towards, not everyone, but some of these ions will go towards the plates until this thing is balanced. But the thing is, this one will never get balanced as long as these wires are connected, because these wires are actually continuously using up the energy, right? So this chemical force will always be greater than electric force as long as this external wiring is connected. Only when you disconnect the external wiring, there is a possibility of chemical force becoming equal to the electric force. Okay, and when you say a battery is drained out, my battery is not working anymore. The reason if we say that is when all these ions, they just attach to the plates and there are no new ions inside. When there are no new ions, we say the battery is drained out. So that's it, guys. That's about the entire battery, the story of a battery. Every battery works with the same principle. So I tried my best to give you the foundations for this battery technology. And I hope you're reading your textbooks. Without reading the textbooks, whatever effort you're putting in listening, you'll just forget everything in a day or two. So make sure you spend time at least within 24 hours after each lecture. Try to revise whatever we are discussing. Now we are done with battery, we are left out with EMF. And before we move on, I can take any questions. You can also speak if you want. If you have any questions about the battery, this is the time to address. Any questions? No questions? Is it that clear? Amrit, Hasini, you guys always have questions, right? No questions this time. All right, okay. I have chat window active. Okay, no questions. Niyati just gave me that there's no questions. I hope you understood. And when you read the textbook, There are a lot of other points. Your textbook doesn't explain why the electrolyte can create chemical force. It doesn't explain clearly why sometimes chemical force is greater than electric force. But since now you understood the entire picture, when you read, it should be more clear. Okay, and you also can do your own research. Online is a great thing. You have Google search, you have Wikipedia, everywhere you can find information. That's how you do research. It's called literature survey. Research people call it as literature survey. Now let's move on. I want to define what is electromotive force. Okay, I have a question from Amrit. So then what happens when we recharge a rechargeable battery? Okay, so that's a wonderful question, Amrit. And I completely forgot about that. We talked about non-rechargeable batteries till now. The only difference between rechargeable and non-rechargeable is whatever's happening here. If you observe this right side and left side, there are lots of chemical reactions that are happening. When these ions attach, let's say one of them is a zinc plate, other one is a manganese dioxide plate or whatever. When these ions go and attach there will be a lot of chemical reactions that happen. So these chemical reactions are sometimes permanent. When chemical reactions are permanent reactions, then this part, okay, so we have 10 minutes, guys, so we can continue with this battery and hopefully EMF also. So when these chemical reactions are permanent, that's a non-reusable battery or non-rechargeable battery. But with rechargeable batteries, what happens is when you force current, I mean, here electrons are traveling this way and here electrons are traveling this way. All we have to do is we have to push electrons in this direction and we have to pull electrons from this plate. When you do that, that means you have to externally, you have to take a powerful battery and connect that powerful battery in reverse polarity to this battery. Okay, when you do that, the external, I mean, all these electrons over here will be pushed inside and all the electrons here will be pushed outside. So when that happens, the chemical reactions that are happening or that have happened before, they become reverse. That means zinc will not become as a new material. Zinc will, I mean, let's imagine before zinc has changed to zinc chloride. But since this is a reversible reaction this time, you can convert that zinc chloride to zinc, and this manganese dioxide, which converted to sodium manganate or some other compound, you can convert it back to manganese dioxide. I just gave a random example, guys. In fact, you cannot convert it that easily. But the only difference between rechargeable and non-rechargeable, in rechargeable batteries, these chemical reactions that have happened, you can reverse them by just allowing electrons to flow in the opposite directions. In non-rechargeable, there's a permanent change in compounds and that new compounds cannot conduct electricity. So that's what happens with rechargeable and non-rechargeable batteries. All right, so Hasini has a question. Sir, at last, do the inner ions attach to the plates? I mean, actually, Hasini, this particular analysis given by the textbook, it's actually extremely simplified version, very simplified version. It's so simplified, you're using the symbols like balls or something like this. In reality, these ions don't attach like this. They actually join with this metal, permanently join as a new compound. So this, for example, this sodium ion reacts with the manganese dioxide on this plate and it changes into a new compound. So ions, you will never see really ions like balls attached over there. The entire material actually changes. It's the structure, its chemical composition, everything gets changed. So ions, they do attach to the plates, but on top of attachment, they actually chemically react and form new compounds on these plates. Okay, so that's about the questions that you had, and both were amazing questions, wonderful questions. Yeah. That's about thinking. At least one of those questions is out of the box thinking, innovative questions actually. Now, let's think about what's happening here. Now, if you observe carefully, in stage 3, if you remember stage 3, guys, I'm bringing our discussion to, I'm bringing our discussion to, what was that, to EMF, electromotive force. This is stage 3, if you remember. Both FC and FE are balanced out, right? And as soon as you connect it to an external wiring, Fc is greater than Fe, so the ions will start move towards the plate. The inner ions will move towards the plate. Now please observe carefully. Let's say this entire dimension, the length of this battery is, for example, D. Okay, the length of this battery is D. And here, imagine what's happening over here is the effect of chemical force. So this is the chemical force. Fc is the chemical force. And when you connect it to an external battery, I will go to the next slide. Yeah, I will go to this slide. Here, Fc is greater than Fe. You already know the reason, because of these electrons that are disturbing the whole thing. So as soon as Fc becomes greater than Fe, so what's happening on this ion? For example, observe this particular ion. It's very, very close to this plate, the negative plate. It is extremely close to the negative plate. Why it is extremely close to the negative plate? Because these are negative ions. It kind of feels that I can go over there, I can flirt with this particular thing, kind of, because it's a positive ion, it's a negative ion. It kind of, so what happens at this particular time is the chemical force, it pulls this positive ion, which is very close to this negative plate, it pulls it from here all the way towards here. Okay, all the way towards the right side. Once again, listen carefully. This chemical force is actually pulling the positively charged ion that is close to the negative plate all the way towards the positive plate. Same thing is happening to this particular red color one. Red color one is the negative ion. It's very close to the positive plate. So the same chemical force is also applying this force on this red color, a negative ion, from the which is close to the negative plate, and it is pulling all the way towards the which is close to the positive plate, and it is pulling all the way close towards the negative plate. Okay, so don't get confused. It's simple. Chemical force is pulling positive charges from the negative plate towards the positive plate, because it needs to go to the positive plate. And chemical forces are also pulling negatively charged ions from the positive plate towards the negative plate. Let me check the question. All right, no new questions. All right, so I want to repeat this in Telugu in case someone missed out on that particular explanation. Ikkada, right. So I have a new question actually. So that particular question is given by, okay guys, Rahul, Bhargav. Again, Rahul, don't tell that it's not you. I know it's not you. If it is someone else, please stop. You just started disturbing, I guess. I'm getting hello messages, namaste. Stop doing that. Focus on the class. And I have a question from Hasini. Sir, why are the ones very close to the plate? So I'm talking about very close to the plate. First, I'll explain in Telugu and I'll address Hasini's question. So ఇక్కడ chemical force ఏం చేస్తుందంటే ఒక పని చేస్తుంది. It's doing a work. ఆ work ఏంటి? Close to the plate, very close to the plate. In fact, అన్నిటి మీద ఈ ఫోర్స్ యాక్ట్ అవుతుందన్న, ఎవ్రీవేర్ ఇట్ ఈస్ యాక్టింగ్. మనం ఏంటంటే ఎక్స్ట్రీమ్ కేస్ ని అబ్జర్వ్ చేస్తున్నాం. వెరీ వెరీ ఎక్స్ట్రీమ్ కేస్, చాలా పని చేయాల్సిన సిచ్యువేషన్ ని అబ్జర్వ్ చేస్తున్నాము. సో ఈ నెగిటివ్లీ చార్జ్ పార్టికల్ పాజిటివ్ ప్లేట్ దగ్గర ఉందనుకోండి, సో దాన్ని ఆల్ ద వే negatively charged ion should be taken back to the negative plate. Similarly, positively charged ion which is close to the negative plate, దాన్ని కూడా బ్యాక్ టు ద పాజిటివ్ ప్లేట్ తీసుకెళ్ళాలి. మీకు గుర్తుంటే కెమికల్ ఫోర్స్ చేసే పనే అది. పాజిటివ్ చార్జెస్ ని పాజిటివ్ ప్లేట్ వైపు తీసుకెళ్తుంది, నెగిటివ్ చార్జెస్ ని నెగిటివ్ వైపు తీసుకెళ్తుంది. సో ఈ వర్క్ డన్ మాక్సిమం ఎక్కడ ఉంటుంది అంటే ఈ కార్నర్స్ చివర్లలో ఉన్న మిస్ప్లేస్డ్ అయాన్స్ మీద మాక్సిమం ఉంటుంది. దాన్నే మనము ఎలక్ట్రోమోటివ్ ఫోర్స్ అంటాం. అండ్ హాసిని, వండర్ఫుల్ క్వశ్చన్. What you asked is absolutely correct. Why are we only talking about the extreme cases? EMF, electromotive force, is defined for the extreme case. That's why we were talking about extreme cases. But such chemical forces will act everywhere. But maximum force will be at these corners. These ions which are at corners, maximum force should be applied on those ions. So that is the reason EMF is defined in a way it is defined. Okay. So let me check. It seems there is another question. So